So this is also an example on completing a table involving a two-variable equation. Again, a two-variable equation, notice how they're giving us the values for x, but notice how they chose -2, 0, and 2 for the x's. One of the reasons they did this is because since the denominator of the fraction is a 2, this makes the math easier without using a calculator, because when you have a denominator 2, that means you're dividing by 2. And notice how all three of these numbers are divisible by 2. So they're going to make this math rather easily. So you don't necessarily have to use your calculator to do the computations. So again, the way this kind of works is you kind of have this input-output concept where x is what's being replaced. So what they're asked to do is your function is going to be, you're going to be multiplying 3/2 times some number, and then you're going to be losing 4. That's our order of operations here, is 3/2 is going to be multiplied by the x, or I should say the x is being multiplied by the 3/2, and then we're going to be losing 4 after that. So the first thing they're asking us to do is substitute a -2 in. So the -2 is going in for x, and then all we got to do is perform the indicated operations to find the y value, if you will. So notice how the 2's will divide out. 2 divided into -2 is going to give me a -1. And then 3 times -1 is -3. And then we have this -4. Now remember, -3 minus 4 also means -3 plus -4. So again, I kind of use a circle method here when I see these, because to see terms, use a circle. So -3 is my first term, and then the second term, when I circle the subtraction sign, this becomes -3 plus -4. So I really don't have to rewrite this on paper. I'm just kind of doing it mentally as that. So what I'm seeing is a loss of 3 and a loss of 4, which means that's a loss of 7. So -7 would be my loss. So from there, we'll reload this thing. So the next thing they want us to do is substitute 0 in. So 0 goes in other words, this x is going to get replaced by 0. So then all I got to do is perform the indicated operations. So when you multiply by 0, this just turns into 0. So it's 0 minus 4. So in other words, again, thinking this as this is a 0 and a -4, if you will. I really think of this as addition. So if I start with 0 and I have a loss of 4, that means the answer is going to be a loss of 4. So 0 went in and -4 came out. And then similarly, I can substitute the 2 in. So if I put a 2 in, notice how the 2's will go in each other. 2 goes into 2 one time. So this is 3 times 1, which is 3. And then I have a 3 minus 4. Again, the way I see this is the first term is a 3, and the second term is a -4. So if I have a gain of 3 and then I lose 4, I'm in the hole. So I'm actually subtracting here. So my math actually is 4 minus 3. So I have a 1, but I got to pay attention, though, that this is actually a loss of 1 because you lost more than you gained. So the kind of 3 minus 4 basically means you have 3. You're going to be losing 3, and then you're going to be losing 1. So 3 lose 3 is 0, but then you still got to lose 1 more because you're losing 4 altogether. So therefore, you have a loss of 1. So notice how you can kind of break this apart and see it this way as well, where that's a 0 pair, but you still lose 1. So I have a -1 there. So if I look at this over here, some things you can also pick up on is patterns. Notice that if you look at the y's, from a -7 to a 4, that's a change of 3. -2 to 0, that's an increase of 2. That's a change of 2. If you go from a -4 to a -1, notice how that's also an increase of 3. If you go from 0 to a 2, that's an increase of 2. So notice that there's a constant rate of change, if you will. The y's are continually changing by 3, while the 2's are continually changing by a 2. What's interesting is, notice that the coefficient of x is this 3/2. So that's a pattern that we're going to start to pick up on. That's what this table is trying to help us recognize is there's this pattern, there's this rate of change, which in math, they describe that as slope. So this example here is trying to help us also see what's called slope. So this coefficient here helps us recognize some patterns in the problem. Slope is very useful in identifying solutions.